Bismillahirrahmanirrahim. So let us see this problem. A short circuit tester has a red light to indicate that there is a short circuit and a green light to indicate that there is no short circuit, right? So consider an experiment consisting of a sequence of 3 tests. In each test, the observation is the color of the light that is on at the end of a test. An outcome of the experiment is a sequence of red and green lights. So we can denote each outcome by a 3-letter word such as RGR. The outcome that the first and third lights were red but the second light was green. So we are making 3 tests, right? In experimental system, a sequence of 3 tests. So at the end of each test we have either a green or a red light, right? So when we perform 3 tests, we will have a combination of R and G, a 3-letter word, right? As an example, this RGR, that the outcome that the first and the third lights were red, but the second light was green. We denote the event that the light N was red or green by Rn or Gn. Light N means light 1, light at the end of first test, second or third test, right? Now suppose that each outcome is equally likely. Are the events R2 that the second light was red and G2 that the second light was green independent? Are the events R1 and R2 independent? So R1 is event in which case the first light is red, and R2 is an event in which case the second light is red, right? So there are 2 parts to the problem. Number 1, are the events R2 and G2 independent? Are R2 and G2 independent? And part B, are the events R1 and R2 independent? Are R1 and R2 independent? So events R2 and G2 independent if R2 and G2 are independent if the probability that R2 intersection G2 is equal to probability of R2 multiplied by probability of G2. If this holds, then events are R2 and G2 independent, right? Similarly for R1 and R2, R1 and R2 are independent if probability that R1 intersection R2 is equal to probability of R1 multiplied by probability of R2. So if these conditions hold, then these events R2 and G2 is independent if this holds, and R1 and R2 are independent if this holds. So let us find out whether these conditions hold for these events or not. So towards this end, we must first find out the sample space of our experiments. We are performing a sequence of 3 tests, right? So we have either R or G for each place, right? So the sample space of this event, of this experiment, can be, for example, if all the lights are red, for example, first at the end of first experiment is red, the second red, then the third is red, then we have RR, right? Then we have RR, for example, green, right? So we can actually consider R as a 0 and G as a 1. So a sequence of zeros and ones will help us produce the sample space. So for example, if we have a combination of zeros and ones, so we have 0 0, then 0 0 1 0 1 0, right? Binary 1, binary decimal 2 1 0, right? 0 1 1, which is decimal 3, 1 0 0 decimal 4, 1 0 1, 1 1 0, 1 1 1, 0 to 7, right? So we can consider R as a 0, right, and G as a 1. So using this we can write down our sample space. So for example, this will be R G R, then we have R G G, right, then we have G R R, right, then we have G R G, right, we have G G R, and then all green. So this is a sample space of our experiment. Sample space, right? So each outcome, it's given that each outcome is equally likely. Each outcome is equally likely. So the probability of each outcome is 1 over 8, because there are total 8 outcomes, 1 2 3 4 5 6 7 8. So probability of each outcome is 1 over 8, as all the outcomes are equally likely, right? So let's now the first problem that we need to determine is are R2 and G2 independent? So let's find out the events R2 and G2 first. So R2 is an event where the second light is red, right? So the second light is red, R2. So the second light is red here in this outcome. So R, 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 and here too. So R, R, G. Then no, not here, because it is green. This is green, and this G, R, R, right, and G, R, G, right, and yes, here it is green. Second event, second is green. So this is the event R2, and the event G2 is the event where the second light is green. So we have a second green here, R, G, R. We have second green here, R, G, G, and then we have here G, G, R, and we have here G, G, and G. So these are events R2 and G2. So we have already discussed that R2 and G2 are independent if this holds. So let's find out the intersection R2 and of R2 and G2 and its probability, then find out the probability of R2 and G2 as well. So probability of let's find out the intersections R2 intersection G2. So let's see if there are any outcomes which are common. So we see that here the second light is red, and here the second light is always green. So there are no common events. So this is a null set, empty set. The intersection is empty sets, and therefore the probability of R2 intersection G2 is equal to probability of null set, which is 0, right? Now let's find out the probability of R2. Probability of R2 is equal to probability of this outcome, then this outcome, then this. That is, probability of R2 is equal to probability of RR plus probability of RRG plus probability of GRR plus probability of GRG, and the probability of each outcome, as is known, that is 1 over 8. So probability of R2 is equal to 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8. So that is 4 over 8, that is 1 over 2, right? Similarly, probability of the event G2 is the same, right? This is 1 over 8, 1 over 8, 1 over 8, 1 over 8, and that is 4 over 8, that is 1 over 2. So probability of R2 multiplied by the probability of G2 is equal to 1 over 2 plus 1 over multiplied by 1 over 2 is equal to 1 over 4. So for example, this is 1, suppose, and this is 2. So comparing 1 and 2, we can see that probability of intersection of R2 and G2, probability that R2 and G2 is equal to, is not equal to, sorry, probability of R2 multiplied by probability of G2. So we conclude that R2 and G2 are not independent, or they are not independent, because as you see, knowing that the second light is red will make it certain that it cannot be green. So the event R2 does affect the event G2. So that's why they are not independent, right? Now the second part, this was our first part, R2 and G2, and now the second part, whether R1 and R2 are R1 and R2 independent. This is our second part. So we have already found R2 here. Let's now find out the event R1. So the event R1 is the event where the first light is red. So this RR will be part of this event, this outcome, then RRG, then RGR, and then RGG, right? And here in these last 4 events, the first light is always green, so these are not part of this event R1. So let's now find out R1 intersection R2, right? So this is R2 and this is R1. As we can see, this outcome is common to both RR, right? This RRG is common to both, right? This GRR is not here, this GRG is not here, and these two events are not here. So this is the intersection of R1 and R2. So probability of R1 and R2 occurring together is equal to the probability of RR plus probability of RRG, and this is 1 over 8, because these outcomes are equally likely and the probability of each outcome is 1 over 8. So the probability of R1 and R2 occurring together is 1 over 8 plus 1 over 8, that is 2 over 8, that is 1 over 4. Let's call this 3. Now probability of R1, this is R1, so this is the probability of this outcome is 1 over 8, 1 over 8, 1 over 8, and 1 over 8, so that is 4 over 8, right? So that is 1 over 2. Likewise, the probability of R2, as we have already found here, again is R2 is 1 over 2 here, right? This is 1 over 2. So probability of R1 multiplied by probability of R2 is equal to 1 over 2 multiplied by 1 over 2 is equal to 1 over 4. Let's call this equation 4. So comparing 3 and 4, we can see that probability of R1 intersection R2 is equal to the probability of R1 multiplied by the probability of R2. So this equality holds for in this case. So we can say that R1 and R2 are independent. If you see, if the first light is red, it will not affect whether the second light is red or not, right? So, so that's why these two events are independent. So in the first case, the part A, R2 and G2, So R2 and G2 are not independent, but R1 and R2, these are independent. So this completes our solution.